At the western edge of Washington, where the Olympic Mountains meet the Pacific, there is a landscape that seems untouched by time. Dense forests cover the mountains, rivers cut through valleys, salmon return from the ocean, and rain can transform the ground into mud, roots, and moving water. For the Quinault people, this is not simply wilderness, it is homeland. The Quinault Indian nation has depended on the Quinault River and Pacific Ocean for generations. Their cultural knowledge is tied to salmon, the seasons, mountains, and coastline. But this landscape has another story, one written beneath the ground. Lake Quinault, surrounded by steep forested slopes, looks peaceful today. Yet beneath its surface, scientists have found evidence that the valley has been repeatedly disturbed by enormous landslides and powerful earthquakes. Some of those events may have been connected to the geological system capable of producing the largest earthquakes on the Pacific Northwest coast, the Cascadia Subduction Zone. It lies offshore, where the Juan de Fuca Plate is being forced beneath the North American Plate. Most of the time, nothing appears to happen. The land seems still, but deep below the ocean. Pressure continues building. When that pressure is released, the consequences can reach far inland. Researchers studying sediments beneath Lake Quinault have identified evidence of at least 3 major disturbance episodes during the last 3,000 years. The events include underwater slope failures, landslides, changes in river sediment, and other signs of violent geological disruption. The lake preserves a record of disasters that happened long before modern instruments, and that makes the place extraordinary. A mountain can collapse, a river can be blocked, a slope can suddenly move, and when enormous amounts of earth enter water, the water itself can become dangerous. In 2025 and 2026, the U.S. Geological Survey developed models showing how a hypothetical landslide beneath Lake Quinault could generate tsunami waves inside the lake. The purpose was not to predict such an event. It was to understand what the landscape is capable of. That distinction matters, because this story is not about a mountain literally being thrown into the sea. It is about something more interesting: how Indigenous people learned to live in a landscape where mountains, rivers, forests, and the ocean were constantly connected. The Quinault did not need modern instruments to understand that the land could change. Their survival depended on observing it. Today, science is discovering how dynamic this place really is. The ground beneath the Olympic Peninsula contains evidence of earthquakes that struck centuries and millennia apart. The slopes around Lake Quinault preserve traces of ancient failures. And along the Pacific coast, native oral traditions preserve memories of changing shorelines and environmental events. Geology reads the layers beneath the lake. The Quinault remember the land above it. Together, they reveal a landscape that has never been as stable as it looks. To understand what the Quinault knew, we have to begin with the force beneath Pacific that has been reshaping this coastline for thousands of years. The Olympic Peninsula is a place where the boundary between mountain and ocean is unusually thin. Rain falls on the high country, becomes streams, and races downhill toward the Pacific. Forests hold the slopes together, while rivers carry enormous quantities of sediment toward the coast. For thousands of years, the Quinault watched this system closely. The river was not simply water moving through the valley. It was a source of salmon, transportation, food, and life. But rivers can also reveal when the mountains have changed. A landslide upstream can suddenly fill a channel with debris. A blocked river can form a temporary lake. A powerful earthquake can destabilize entire hillsides at once. And the Olympic Peninsula has experienced all of these forces before. The reason is hidden offshore. The Cascadia Subduction Zone stretches for hundreds of miles along the Pacific Northwest. Here, the Juan de Fuca Plate is slowly being pushed beneath the North American Plate. The two plates do not move smoothly past one another. Instead, portions of the boundary can lock together while pressure accumulates. Then, eventually, the locked section can rupture. The result is a great earthquake. When that happens offshore, the ocean floor itself can move suddenly. The water above it is displaced, generating tsunami waves that can travel toward the coast. Scientists know this has happened repeatedly. They have found buried layers of sand and mud along the Pacific Northwest coastline that were deposited by ancient tsunamis. Tree rings provide another clue. In 1700, a massive Cascadia earthquake caused coastal land to suddenly sink in parts of the region, killing forests that were later preserved as ghost forests. Japanese historical records independently documented an unusual tsunami arriving without a local earthquake on January 27, 1700. Together, these clues revealed something extraordinary. The Cascadia earthquake was not simply a possibility. It was part of the region's history, and it changed the landscape. The Quinault homeland sits directly within this dynamic environment. Lake Quinault itself occupies a valley surrounded by steep mountains and forest. Sediments accumulating on the lake floor act like pages in a book. Every layer can contain clues about what happened around the lake when that material was deposited. Researchers can examine changes in grain size, chemistry, organic material, and other characteristics to identify periods when unusually large quantities of sediment entered the lake. Some layers are ordinary, others are not. The unusual layers indicate episodes when the landscape was disturbed on a much larger scale. Massive slope failures can send enormous quantities of earth into a lake. Earthquakes can trigger these failures almost simultaneously across a region. A single seismic event may leave evidence in several different environments at once. That is why scientists compare geological records from lakes, rivers, coastal marshes, and the ocean floor. If the same period appears repeatedly across different locations, the evidence becomes much stronger. The mountains begin telling the same story from multiple directions. And that story is one of repeated disruption. The important point is that none of this means the Quinault were helpless in the face of nature. Quite the opposite. Indigenous societies throughout the Pacific Northwest developed their lives around landscapes that were constantly changing. Knowledge of rivers, tides, weather, forests, animals, and mountains was accumulated through generations. A person who knew a river intimately could recognize changes that an outsider might miss. A sudden change in water level, unusual debris floating downstream, a slope that had begun to crack, a river behaving differently than it normally did. These observations were part of living in the landscape. Modern geology measures the same environment with instruments, sediment cores, satellite data, and models. But the fundamental lesson is similar. The mountains are not permanent. The river is not permanent. Even the coastline is not permanent. Everything is moving, and somewhere beneath the Pacific, the tectonic plates are still moving too. That is what makes the old stories and the geological records so compelling. They come from completely different forms of knowledge, yet both begin with the same observation. This land can change, sometimes slowly, sometimes in a single moment. And when the mountains finally move, whatever is standing below them has to move too. There is another reason the landscape around Lake Quinault is so important. The evidence of ancient disasters is not limited to the mountains. It can also be found in the trees. Along the Pacific Northwest coast, scientists have discovered forests of trees that once stood on dry land but were suddenly drowned by salt water. These ghost forests preserve the memory of enormous coastal earthquakes that caused sections of the shoreline to drop suddenly. The trees did not slowly die as the climate changed. They were killed when the land itself moved. In some places, their remains can be dated to within a few years of the same period. When those dates are compared with tsunami deposits preserved along the coast, the evidence points toward massive earthquakes originating along the Cascadia Subduction Zone. The most recent Great Cascadia earthquake occurred in January of 1700. The earthquake was so powerful that sections of the coastline suddenly dropped. A tsunami crossed the Pacific and reached Japan, where historical records describe an unusual wave arriving without an obvious local earthquake. There was no seismograph in North America recording the event, no newspaper describing the destruction, no photograph. But the landscape remembered. The trees remembered. The sediments remembered. And indigenous communities preserved their own memories of catastrophic events through oral traditions passed from generation to generation. For the Quinault and neighboring peoples of the Pacific Northwest, stories of floods, changing landscapes, and powerful supernatural beings were not written as geological reports. They were stories about the world, about mountains, about rivers, about the ocean, about forces powerful enough to reshape the places where people lived. This distinction matters. It would be a mistake to take an ancient story and claim that every detail describes a specific earthquake or landslide. Oral traditions carry cultural, spiritual, and historical meanings that cannot simply be translated into modern scientific terminology. But it would be equally mistaken to assume that such traditions have nothing to teach us about the past. Indigenous communities observed these landscapes for generations. They noticed changes in rivers. They remembered unusual floods. They passed knowledge of dangerous places to their descendants. And sometimes, those memories may preserve information about environmental events that occurred long before written records existed. Modern researchers have increasingly recognized the value of this knowledge, not because traditional stories need science to make them valid, but because archaeology, geology, and indigenous knowledge can illuminate different parts of the same landscape. At Lake Quinault, that landscape is still moving. The Olympic Mountains continue to erode. Rivers continue carrying sediment toward the Pacific. Slopes continue to shift, and the tectonic plates beneath the ocean continue accumulating pressure. The next great earthquake is impossible to predict precisely, but scientists know that Cascadia has ruptured repeatedly in the past, with major earthquakes separated by centuries. That knowledge changes how we see the peaceful landscape surrounding the lake. The forest no longer looks completely still. The mountains no longer look permanent. And the water no longer appears to be simply a quiet reflection of the trees. Everything around it is part of a system that has been changing for thousands of years. For the Quinault, that reality was never theoretical. Their homeland was built around a river that connected the mountains to the ocean, and when the mountains move, that connection can carry the consequences all the way to the sea. The question is not whether the landscape will change again. It is when. And what will remain to tell the story when it does. The mountains around Lake Quinault may look permanent. They are not. The valley has been shaped by rivers, landslides, glaciers, earthquakes, and the slow movement of the earth beneath the Pacific. Some changes took thousands of years. Others happened in moments. That is what makes this landscape so important. The Quinault homeland exists in a place where the mountains and ocean are connected by forces that cannot be seen from the surface. Rain falls in the high country. Streams gather into rivers, sediment moves toward the coast, and deep beneath the Pacific, tectonic plates continue pressing against one another. The landscape is never truly still. Modern science has given us a way to read some of the evidence left behind. Sediment buried beneath lakes can reveal ancient disturbances. Trees killed by sudden coastal subsidence can preserve the timing of past earthquakes. Tsunami deposits can mark waves that arrived centuries before written records, and geological layers can show when mountainsides suddenly collapsed into valleys and waterways. Together, these clues reveal a Pacific Northwest repeatedly transformed by enormous natural forces. But science is not the only way this landscape remembers. The Quinault have maintained a relationship with these mountains, rivers, and waters for generations. Their knowledge comes from living within the environment rather than simply studying it from outside. That distinction is important. A geological core can tell us that something happened. An archaeological site can tell us what was left behind. But cultural memory can tell us why a place mattered to the people who lived there. And that is what makes the story of Lake Quinault more than a story about earthquakes and landslides. It is a story about a homeland that has always been changing. The mountain does not stand apart from the river. The river does not stand apart from the sea. And the people who live there do not stand apart from any of them. Everything is connected. The title of this story asks what the Quinault said, the mountain sent toward the sea. The answer is not necessarily one single catastrophic event, it is something much larger. For thousands of years, the mountains have been sending water, rock, soil, trees, and sediment toward the Pacific. Occasionally, earthquakes and landslides accelerate that process, transforming the landscape in ways that can remain visible for generations. The Quinault learned to live within that system, and modern science is only now beginning to reconstruct how dramatically it has shaped their homeland. So the next time you see a photograph of Lake Quinault, look beyond the reflection on the water. Imagine the slopes above it shifting. Imagine ancient rivers carrying sediment through the valley. Imagine earthquakes powerful enough to move entire sections of the coastline. And imagine the generations of Quinault who watched this landscape, learned its patterns, and passed that knowledge forward. The mountains are still there. The river is still moving. The Pacific is still waiting beyond the forest. And deep beneath it all, the earth is still moving too. If you enjoyed this documentary, subscribe to the channel. We will continue exploring the places where indigenous memory, archaeology, and modern science reveal the hidden history of North America. Because sometimes the most important stories are not buried in ancient ruins. They are written into the mountains themselves.